Okay, this is the first video on the semester review solutions, and I'm not going to read this. I'm going to highly suggest that you do it, and it'll help you out a lot. So anything that's in writing is your responsibility. So this first video is going to be video questions 1 through 10. So we'll go ahead and move on to question 1. In a sample survey, what is meant by bias? Well, we remember that bias is overrepresenting or underrepresenting part of the population. And generally speaking, it's a systematic error or a systemic error in sampling method that leads to an unrepresentative sample. In other words, the sample does not look like the population. The best answer in this case is letter A. I don't know what's going to show up best, but we'll try it out here. So letter A, that doesn't show up very well. Maybe if I just circle it. So letter A ends up being our best choice. All right, part 2, question 2. A telephone survey with regard to support of a bond issue resulted in the table below. Well, we have the table and it's broken down by age category. And then we have how they voted for and against. So in 21 to 30-year-olds, we had 45 vote for it and 30 vote against. So what is the probability, which of the following sample strategies was most likely used? Well, we broke it into groups, and if we break it into groups, it's going to either be a cluster or a stratified. So it's going to be one of those two. But remember, for it to be a cluster, everything in the group has to represent the whole population. So the group would have to have all age groups, and this does not. So this is probably a stratified. Why? Because everyone has a common characteristic. They're all in this age category. This group is always in this age category, etc. So because it's broken down on a common characteristic, this makes this a stratified sampling method. All right, next page, number 3. Sampling error is, well, sampling error is basically because we're using a sample statistic to represent the population. All right, we're using a sample statistic as an estimate for our population. And because we didn't sample the whole population, we're likely to have error, and that is sampling error. The difference between a population parameter and the estimate of that parameter, which is the sample statistics. This would be letter E. A human resources department, this is number 4, a human resources department plans to survey 100 of the 3,000 employees in its firm. An alphabetical list of the employees is available. A random number between 1 and 30 is picked. And the sample consists of persons that far down the list, together with every 30th person after that. So we're selecting every 30th person. So anytime you do every nth person, we are talking about a systematic sample. We randomly select the first one, and then it's every nth one after that. Number 5, before taking an exam, students either went to bed at their normal times or were sleep deprived for 4 or 8 hours. Half of each group were given a caffeine pill before taking the exam. Determine the number of factors, which means the number of variables, the number of levels, and the number of treatments. So I'm going to kind of diagram this real quickly. So basically, we have students. I'm going to draw a box for the students, and either they got normal sleep, minus 4 hours sleep, or minus 8 hours of sleep. And then they were either given a caffeine pill before the exam, and the half were, and then half were not. So we have caffeine, no caffeine, caffeine, no caffeine, caffeine, and no caffeine. All right, so I have, in this case, I happen to have 2 variables, which are sleep, and the other is meds. So there's 2 variables, so that means I have 2 factors. This one has 3 levels, and this one only has 2 levels, caffeine or no caffeine. And if I multiply 3 times 2, gives me 6, So I have 6 treatments. So I have 2 factors, one that had 2, caffeine and no caffeine. The other had 3, normal sleep, deprived 4 hours, deprived 8 hours. So in this case, my answer is letter D. What is bias in conducting surveys? Once again, it's overrepresenting or underrepresenting part of a population. So in this case, letter E, a tendency to favor the selection of certain members of the population, to overrepresent or underrepresent part of the population, to favor a group. 7, a botanist is running an experiment on 2 fertilizers that require different amounts of watering. She has 40 test plots, half of which are in a sunny location, half are in the shade. So basically, she's blocked on sun and shade. She randomly selects 10 sunny plots and 10 shady plots for which she used 1 fertilizer. This is appropriate watering, while the remaining plant plots are for the other fertilizer with its appropriate watering. So we have random assignments and blocks, that's good. Of the following, which is the most important observation about this procedure? The variables water and fertilizer are confounded. This is actually our answer. And the reason this is the answer is they require different amounts of water. So we don't know if the plant is growing due to the fertilizer or due to the water. Here it says fertilizer and sun are confounded. No, they blocked on that. So they took care of the lighting situation. So that's why it is not that one. That's the one that's most easily to confuse. Pause for just a moment. Okay, we're going to move on to question number 8. A television network conducts a weekly survey to determine the proportion of viewers who watch various programs for the coming year. They decide to double the sample size. The main benefit of this, well, we can't fix bias. So increasing sample size doesn't do that. We can never eliminate sampling error. We can minimize, but we can't eliminate. Decrease the population variability. You can't change what the population is. The population is what it is. But we can decrease the standard deviation of the sampling distribution. Letter E, we can decrease the standard deviation of the sampling distribution. We can also decrease the sampling error, which means the same thing, but we cannot change it for the population. The population is what it is. Which of the following statements is incorrect? And I'm just going to tell you, it helps when if they ask for an incorrect or something that's not, just to make a list of true, false. So voluntary response samples often underrepresent people with strong opinions. That's true. Excuse me, often underrepresent. No, they don't underrepresent them, they overrepresent them. So that's false. Convenient samples often lead to undercoverage bias. Yes, they do. Convenient sample is when you survey those that's convenient to you, and generally speaking, that leaves out part of the population because you're surveying those that are easy to access or together. Questionnaires with non-neutral wording are to have response bias. That's kind of the definition of response bias, so that's true. There's no way to fix the results of a bias sampling method if a bias sampling method was employed. That's true. If you have biased data, you have to throw it out and start over. Non-response bias should be avoided because who do not respond may have different views from those who do respond. That's true. So you need to make sure you have a representative sample. So the only one that was false was letter A. And in fact, voluntary response samples overrepresent people with strong opinions. They don't underrepresent. All right, number 10. Each of the 30 major baseball teams carries a 40-person roster, a sample of 60 players. 5% of all 1,200 players is to be randomly selected to undergo drug tests. To do this, each team is instructed to put their 40 names in a hat and draw 2 names. Will this method result in a simple random sample of the 1,200 baseball players? And the answer is no. To be a random sample of baseball players, you would need a single hat where you put all 1,200 players in and drew. Here we have 40 hats. So this would be a stratified sample, not a simple random sample, but basically because they only used one hat. If they had only used one hat, yes, it would have been a simple random sample. Because they used 40 hats, and then, in other words, a hat for each team, this is not as simple, and we made sure that we got someone represented from every team. So, no, because not each group of 60 players has the same choice of chance of being selected. In this particular design, the max number I could get from any one team is 2. However, if this were going to be a simple random sample, it would have been possible, not likely, but possible that I draw all 40 names from the same team. Okay, this will conclude the first video. The next video will cover 11 through 20.